Hello, this is Nosratella. This is lab05A demo. That's for OSC 1436 online. You all have the definition for the problem of part A. We're going to use recursive function to calculate the E or Neperian number. Your structure chart would basically look like this. You have the main and then a function factorial which you're going to be calling. In your main, you're going to set your old E value to be 0 and set the new E value to be 1. You want to repeat this loop while the difference between the new and the old E is greater than 0.000001. If that is the case, you want to continue and set the old E to be the new E, and then you are going to have the new E calculated by having new E plus 1.0 divided by factorial of plus n. Notice that this is adding n before you do the operation, so it's a pre-op increment rather than the post-op. And here is where you call the factorial. You check, and the difference is not that 0.00001, and you keep changing E new with the E old, and every time you go in, the value of n is being incremented starting from 1, 2, 3, and so forth and so on, till the last one that your difference, the delta, will satisfy the loop condition and you want to exit and get out of the program. Here is your factorial function flowchart. When you come to the factorial function, you have the function definition. First thing you do is checking to see is n 0. If n is 0, you want to return a 1, and that's the end of the function. However, if n is not 0, anything other than 0, you're going to return n multiplied by factorial of n minus 1. As long as you have positive number that you call the factorial function, this function keep calling itself. This is the concept of recursive calls. The only way you get out of this function is by return of 1. Let's look at this E calculation. We're going to have, basically using the formula E equal 1 plus 1 over 1 factorial all the way to 1 over n factorial. And you're going to have two E's. One is the old E, one is the new E, and the difference would be what you want to test for. By definition, factorial of 0 is 1, and factorial of 1 is 1. Factorial of 2 is 2 times 1. Factorial of 3 times 2 times 1. Factorial of 4 times 3 times 2 times 1. Factorial of n is n times, if you notice in the red portion, there is n minus 1 times n minus 2 all the way to 1. This is the same thing as n minus 1 factorial. So you can define any factorial of any number by multiplying that number times 1 less than that number. Here is the start of your program, just like a cookbook. Here's your function prototype that you're declaring your factorial to return to you a long integer, and you're passing to it a long number n. Here's your main that you define your old and new, while the old E and new E difference is greater than this delta that you set. You want to recalculate the new E, and when this condition finishes and you jump out of the loop, you want to output your old E and new E and n, which is the number of the succession you went through. Here is your factorial function. It's a recursive function again. It calls itself. And here's the function definition. Start with if n equal 0, you want to return 1. Otherwise, you're going to return n times factorial of n minus 1 multiplied by n. Here's the call it. And this is the end of the function. Here's a walk through the factorial function. Okay, let's say we want to start with the 4. N is 4. Is n equal 0? No. So we're going to have 4 times factorial of 4 minus 1. Now this time n is 3 and call the factorial again. Is n 0? No. So we're going to return 3 times factorial of 3 minus 1. N is 2 this time. You call the factorial. Is n equal 0? No. So we're going to return 2 times the factorial of 2 minus 1. Now n is 1. We're going to test n is not 0. We're going to return 1 times factorial of 0, which is 1 minus 1. Now, n is equal to 1, and in fact we are returning 1 at the end of here. The compiler has been keeping track of all these calls that are waiting for the return result. It keeps putting the results back one by one, and the final result would be 24. So this would be 1 return. This would be 1 times 1 return. This would be 2 times 1 return. This would be 3 times 2 return. This would be 4 times 6 return. And finally 24 is the final result. The end.